Welcome to True Projects. In this video, we are going to explain about a project titled Malware Classification using ML and DL. The term malware derived from malicious software presents a substantial peril to digital frameworks, networks, and the user information. As cyber threats rapidly advance, the conventional signature-based approach for identifying the malware proved inadequate. In response, machine learning and the deep learning methodologies have served as a potent instrument for categorizing the malware, offering the resilient and adaptable solution. This study seeks to delve into the capability of ML and DL algorithms in effectively discerning and categorizing the diverse malware variants. This pursuit not only facilitates the elevated cybersecurity measures but also fortify the defense against evolving and emergent threats. The core aim of this study is to construct an efficient and effective system for classifying the malware utilizing a combination of machine learning and the deep learning methodology. This study entails a set of specific objectives which meticulously assemble a comprehensive and well-annotated data set housing a diverse array of malware samples without feature engineering to extract and extract the pertinent attributes from the malware specimens, capturing their distinctive characteristics in a manner that optimally reflect their essence, and delve into the variety of ML and the DL algorithms to discern the most fitting candidate for the malware classification. And by immersing the selected models in comprehensive training on the meticulously prepared dataset with of assembling techniques to probe into the advantage of employing the ensemble to elevate the classification accuracy and amplify the model robustness. And it undertake the assessment of proposed methodology, universal adaptability and scalability, ensuring its effectiveness traverse across an assortment of systems and networks. This multifaceted endeavor aims not only to advance the malware classification but also to validate its real-world efficacy and resilience against the dynamic landscape of the cyber threats. And these are the basic requirements that are needed to build this project. The software requirements are Python IDE with version of 3.7, Anaconda with version of 3.7 or Jupyter Notebook. Hardware requirements are operating system as Windows, processor of minimum Intel IP, RAM of minimum 4 GB, hard disk of minimum 250 GB. And to know about the flow of the project, these are the steps we need to discuss. The first one is importing the packages. The project begins by importing the packages and libraries forming the basis for the malware classification system, utilizing the machine learning and the deep learning methodology. And the second one is exploring the dataset. The dataset containing the malware images is explored to gain the insight into its content, contributing to its understanding of the available data for the model training and the validation. And the next one is image processing. Images undergo pre-processing steps like resizing, normalization, and the noise reduction to optimize the quality by subsequent analysis. And the next one is extracting the image from the train and the test. Images are extracted from the data set to create the separate training and the testing set. These image sets are converted into the NumPy arrays for the compatibility with the machine learning and the deep learning model. And the next step is data visualization. Data visualization and Matplotlib are the tools are employed for the data visualization, yielding the informative graphic that visually represents the data. And the next step is flatten the shuffle, the train and the test data. Image data is flattened and shuffled to avoid the bias and ensure the random distribution during the model training and evaluation. And the next step is building the model. Here various models are built. The first one is random forest. It is an ensemble learning algorithm that creates the multiple decision trees during the training and combines the predictions for enhanced accuracy. In the context of malware classification, RF can effectively capture the complex relationship between the image feature that indicates the presence of malware. And the next one is decision tree. It is a tree-like model that segments the data based on the attribute value and reaches a classification decision at the leaf node. In the malware classification, decision tree dissects the image features to identify the pattern associated with the malware presence. Despite their simplicity, decision tree can capture the specific decision boundary that contribute to the effective classification. And the next one is KNN. It stands for K-nearest neighbor. It's a classification algorithm that assigns the label based on the maturity class among its K-nearest neighbor in the feature space. In malware classification, KNN measures the similarity between the image features and those of the neighboring image. This proximity-based approach can effectively differentiate between the different type of malware based on feature similarity. And the next one is Inception ResNet V2. Is a state-of-art deep learning architecture tailored for the image classification task. In the context of malware classification, this architecture integrates the design enable it to capture both the low-level and the high-level feature in the images. And the next one is DenseNet 1211. It is another deep learning architecture well known for its efficiency and image classification. Its densely connected layers enable it to efficiently capture the feature hierarchy within the images, and the architecture connectivity pattern facilitate the use of the feature across the layers, potentially leading to the improved accuracy. And the next step is user uploads an image for analysis. Here we are using the Flask as a web interface where the user can allow to upload the image for analysis, enabling them to seek the prediction for the image malicious intent. And the next one is the given input image is pre-processed. The upload images undergo pre-processing to ensure the match the model's input requirement. And the next one is the trained model is used for predicting the result. The trained model chosen during the building phase is utilized to predict whether the input image contains the malware or not. And the next one is final outcome is displayed. The project concludes by presenting the prediction outcome to the user. This typically involves displaying the predicted class, probability score, and possibly providing the additional insight about the image classification. And the execution of the project. To execute the project, first we need to open the code folder. And this is the code folder containing of various files within it, the sample folder containing of the images within it, and the static folder containing of the HTML folders like CSS, JavaScript, images, assets within it. And the template folder containing of HTML documents. It typically include of home, index, notebook, result sign in, and sign up pages within it. And the app is an py file which likely contains the information related to the front-end project. It includes the code written in Python that handle the server-side operation such as processing the user request, interacting with the database, and generating the dynamic content that to be rendered in the HTML template. And the model is a pickle file which contains the combination of the algorithms and loaded into the project code during the runtime to utilize the trained model for the various tasks, such as making the prediction on the new data, performing the specific operations. And the signup.db is a file appear to be the database file that to be used to store the user information. And the notebook is an IPYNB file which contains the combination of code, graph, and output all in one place. It allows the user to write and execute the code in the individual cell, making it a popular choice for the data science. And for the execution of the project, we need to copy this code folder path and then open the Anaconda prompt. Here we need to write a command that is cd space and paste this code folder path. By this it will change the current directory to the code folder path, and then click on the enter button. Here we need to write a command that is python space app.py. By using this command, it will execute the Python script and perform the runtime check for any syntax errors or logical issues. And then click on the enter button. After running this app.py file, the Flask framework will host the application locally at the default address like this. We need to copy this link and paste it on any of the web browser of our choice, and I prefer to use the Google Chrome. I'm pasting this link and then click on the enter button. Here it will redirect it to the speech containing of information and title of the project. And then click on the sign up button. Here it will redirect to the sign up page containing of some necessary details that are need to be filled to create an account. But my account is already created, that's why I'm using the sign in button containing of username and password that are the details that are need to be filled, and then click on the login button. Here it will redirect it to this page containing of the choose file and upload buttons. By clicking on the choose file button, selecting one image and then click on the open button and then click on the upload button. Here the predicted result as of the malware type is of cdlop.judge based on this image, and by using the try again button we redirect back to this file, and then by clicking on the choose file button, here we can select another image and then click on open button and then click on upload button. Here it predicted the output as of malware type is Florida AA1. In this way we can predict the malware type using the machine learning and deep learning techniques. And in conclusion, the research on malware classification using the ML and DL techniques has proven to be the promising approach in enhancing the cybersecurity measures. By leveraging the advanced algorithms and diverse feature set, we successfully built a malware classification model capable of accurately identifying the different types of malware. The performance evaluation demonstrates the ML and DL based classifier outperforms the traditional signature based methods and exhibit the high precision and the recall values. This integration of ensemble techniques further improved the model's accuracy and the robustness, making it suitable for the real-world applications.
Thank you for watching video. For more projects please visit our website www.trueprojects.in. For updates on latest project videos, please visit True Projects YouTube channel and subscribe.